In the last video, we were talking about biodiesel and how to create biodiesel from things like oils, aka vegetable oil. We also said that these diesel engines were running on vegetable oil and peanut oil back in the day. This was kind of dropped though because the price of diesel kind of plummeted, and that was a very cheap alternative source that we could use, and we just got comfortable with it. This concept of vegetable oil, this concept of peanut oil, and so forth, it had been dabbled before time and time again, just like in the gasoline world with biofuel. And then now it seems like we're talking about it more, and we're talking about it like it's a new idea, and it's not. So in the last video, on the last slide, this is where we ended up. And we said that veggie oil can be used to make these different types of products for us in a laboratory. This is biodiesel or organics that are either straight chained or highly branched. And I said, well, what kind of vegetable oil? Okay, what kind of oil? Just totality. What kind of oil? How clean does it have to be? And the answer is that it doesn't. It doesn't have to be clean. What you're seeing on the picture right now, to the left, is filtered used cooking oil. What you're seeing in the middle is the reacted oil with your glycerin or your glycerol. And then what you're seeing on the right-hand side is B100. B100 means 100% biodiesel. I want you to look at this picture for a minute. We're going to kind of process this. First, filtered used cooking oil. Okay, so back in the day, this was a problem. When we started talking about ethanol, we were always referring to farmland. We said farmland was devoted to corn, another product. That product was basically chopped down, processed, converted into ethanol. That ethanol would then be shipped out for fuel supply. This was targeting the origins. Raw. Biodiesel doesn't require this. Biodiesel can take vegetable oil, which is made for cooking purposes, for the food supply, for whatever type of reason that you use vegetable oil at home. Whatever those reasons are, I probably don't need to know. But whatever those reasons are, it's probably being sold in a grocery store or to a restaurant. In the world of biodiesel, what they decided was, we're going to take a different perspective here. We're not going to go to the farmer and say, hey, farmer, we want you to grow crop that we can make vegetable oil with, and then we're going to take this vegetable oil, and then we're going to convert it to biodiesel. What they decided to do is go to restaurants. Folks, think of a Chinese restaurant, all of their deep-fried, nasty oil. Think of McDonald's. Think of Chick-fil-A. Think of all of these fast food restaurants that use oil every single day. They cook your French fries in it. They hand them out the drive-thru. What do they do with the oil? They can't just dump it down the sink. They have to dispose of it. It's going to be classified as waste. A whole new concept comes in here. Because what if we could take that waste and convert it into something usable? It's kind of like one man's junk is another man's treasure. The junk here was spent vegetable oil that was used to cook McDonald's French fries all day. And we could go into a restaurant and we could say, whoa, don't dispose of this. Don't dump this and process it like waste. Give it to us. We will come by. We will pick this oil up from you, and we will take it back to our plant. A whole new concept of where this actually begins now is introduced. We are taking something that is waste, not from farmland, not from crop. We're not siphoning off from the food supply. We're taking waste of all things, and we are converting that into what we are going to be calling biodiesel, something that can run a diesel engine. Well, it's got to be filtered. The reason it's got to be filtered is because we've got to get rid of all the junk. As you can imagine, all of the solid particles and the burnt, crispy pieces of flour and breading and everything else on the inside of these big oil vats that we were picking up, all of that's got to be cleaned up a little bit. So this is a filtered cooking oil that has been used, and we can do a reaction with it, just like we can do a reaction with the regular cooking oil. There is no difference here. So regular cooking oil, unused, or used cooking oil can either be used. Reaction happens. A little bit of methanol, a little bit of sodium hydroxide. It's all it takes, and plop, this is what we get in the middle. We see this area on top. That area on top is going to be where our fatty acids are going to be. This area on the bottom, typically going to be our glycerin. We're then going to take that area that's very golden in color. That's where our fatty acids are going to be located, and that is what we're going to call our biodiesel. And that golden straw yellow color is then going to be cleaned up. And this cleaned up procedure is going to give us B100, which is pure biodiesel that we can put into an engine and we can run a car with. That's right, folks. I can go get used McDonald's vegetable oil, throw a couple of reagents in a lab to it, convert it over into biodiesel, and put this biodiesel into a diesel engine and run it. I don't need diesel from crude oil in order to do that. Well, this was not a new concept. Seems like that's been the moral of the story so far. The theme, at least, right? So, 1990s, we have this attempt with biodiesel. And Germany, not the United States, but Germany actually became the #1 producer for this stuff. In the United States, we were dabbling with this as well, but Kansas City was the #1 producer of it. And if you can imagine, again, a lot of your agricultural-based states are going to have a very strong look at this field, the science, the technology behind it. And the University of Idaho made biodiesel, and they shipped it up, and they gave the biodiesel to Yellowstone National Park. What you're seeing in the picture here is a vehicle, and this vehicle has been ran off of biodiesel from the University of Idaho back in 1995. It actually ran for hundreds of thousands of miles. I mean, I think the odometer on this truck was 300,000 or 400,000 miles before they took it out of service. It was so successful that they said, you know what? This works for Yellowstone, but we're also going to let these other national parks use it across the United States as well. Here at the tailgate, look at what you see. Powered by biodiesel. Folks, this was a step in what they believed was the right direction. We were lowering our dependence on diesel from crude, and we were producing a product that was biodiesel from spent vegetable oil waste mainly. And the University of Idaho had a hand in this, and they were delivering the biodiesel for these vehicles to be powered with, which made them run, which made them do their job every single day. And not only that, but these vehicles, they lasted. It wasn't like biodiesel was gunking up the engines and 50,000 miles in, it was time for a new one. That's not what was going on. This was perfectly okay to put into a vehicle and run. So people began to question, why aren't we putting it in our gas stations? If B100 is getting used in this vehicle and it's okay, then why aren't we using B100 at our gas stations to do the same thing with? Well, during this time, as we begin to talk about fuel alternatives, GE gets into the mix. Big powerhouse. They are involved in numerous different types of projects. And GE was afraid of their energy loss. And they came up with a plan. And they said, well, listen, we know coal, we know crude, we know these things are very dominant, and we know they're probably not going to go anywhere anytime soon. But we want to be ahead of the game. If it begins to happen, we want to be ahead, not behind. So what they decided to do is take a couple of their plants, and those plants were coal and gas power, and they were retrofitted. They went through and they said, okay, we're going to take these plants, we're going to convert them. No longer are they going to be coal plants. No longer are they going to be gas plant. We are going to convert them, and we're going to dedicate that to biofuel. They used biofuel in order to run those plants. What did they find out? There was no difference. It basically supplied them the same amount of energy that they were getting from coal and gas. And not only that, but they weren't polluting as much. I know biodiesel can go in, but biodiesel is made from vegetable oil. Those vegetable oils are basically getting converted to esters. And if you're looking at carbon monoxide, carbon dioxide, other toxic pollutants that come out of a pipeline, what they discovered is that this was, in a way, cleaner. So this was an article that came out during that time. The wood chips are down. GE is building a massive biomass energy plant in Belgium. Oh, it could have been the United States, but GE is a global company, so they decided to go there. Well, the issue here, as you can imagine, was here we are starting to dabble in biodiesel. Here the University of Idaho's dabbling in biodiesel. Here we're proving that we can make biodiesel. This is what it looks like. Here we're proving the theory of biodiesel. This is what's going on, and these are our products. And we are trying to convince people to put it into their gas tank. And you can imagine that people are very hesitant. You probably would be too. If you just spent $20,000, $30,000 on a diesel truck, or in most cases, you're actually probably looking at $50,000 or $60,000 on a diesel truck, then someone's going to tell you that they've made diesel from vegetable oil, and you're going to just take their word from it. You're going to put it into your expensive vehicle, and you're just going to test the waters to see what happens. You can imagine people were very apprehensive to do this. So we have a regulatory body that became involved. And this regulatory body was ASTM. If you don't know what that abbreviation means, I hope you do. But if you don't, I would highly encourage you to look that up before a test rolls around or a quiz. It's one of those abbreviations that we've introduced a couple of times now, right? So ASTM is going to come in, and ASTM is going to set some standards. How can we prove that this biodiesel is actually going to work and is going to be safe to use, and that one biodiesel from one person is going to be the same as another biodiesel from another person? So ASTM International gave us a set of standards. These standards are going to start falling under a code that we call D6751, and they begin to look at all of these different properties of biodiesel. In order to sell biodiesel, in order to market biodiesel as biodiesel, your product has to fit the ASTM standard, because people were going to start looking for this. Is it ASTM approved? Does it meet ASTM standards? If it does, then you kind of know what you're getting. You kind of know the quality of the product at this point. And we can feel a little bit better about the quality of that product. I mean, that's the whole reason that ASTM kind of exists, right? So it allows these companies to feel very confident about what they are purchasing. If you look on the screen, they're actually dissecting biodiesel down into quite a number of different areas. I mean, here we get flash point, water content, viscosity, how thick it is, sulfated ash, total ash, kind of residue that's left behind, copper strip corrosion. You can imagine that if it's going to be exposed to metals and stuff, we want to make sure that, it doesn't do any damage. Cetane number, cloud points, carbon residues, acid numbers, glycerin, phosphorus. All of these different types of markers would have to be done on biodiesel in order for us to sell it as biodiesel. All of these have different method numbers, by the way. It kind of started with one and then it just broke out. It broke down into different areas that we could test. Here are the limits that you're going to find on some of these different types of tests. The limits, of course, are included in the method numbers. And then here are the units that they typically report in. What do I want you to take away from this? What I want you to take away from this is that there's multiple different types of tests that we can do on biodiesel. And for you are going to make biodiesel, and you're also going to test biodiesel that you have made in the lab. But you're not going to test it for all of these. There'll be some, but we're not going to test for every single thing that the ASTM requires us to test. All right? I think that you'll get the picture. You'll get the drift on how pure your product is in a nutshell, general summary, if we only do a handful of these tests instead of every single test that they've listed. And I think you'll be happier with that too, right? So, after the ASTM got involved, people felt much more comfortable with the biodiesel that was getting made from the spent vegetable oils and other related products that we could then put into our engine. 2008, 2005, somewhere in there, we started to see more heavy use of biodiesel that was happening during this time. Again, this was not a new concept. This was nothing new. They had been doing this again before the 1900s. 1930s, first biodiesel came around. We just didn't call it biodiesel at this time. But this was kind of what we would call modern day, our modern day at least, biodiesel usage. And we start to see an increase in the number of different companies that were getting involved. 2004, we had 25 biodiesel plants. 5 years later, 2009, we actually see 200 biodiesel plants pop up across the United States. This was actually a trend. This was something that was talked about in every state. It was something that an economy in every state really wanted to grab a hold of and get involved with. We talked about it in North Carolina, okay? This was something that was discussed. This was something that we even talked about at the college. Offering a biotech or a biofuel degree. That's how serious this became. All right. 2005, the government fleets were required to purchase alternative fuel vehicles. So once again, this just really confirmed the usage of biodiesel. It showed us that biodiesel was not going to go away. If government cars were kind of required to run off of these types of fuels, then we can kind of have an idea that this is going to stay around. 2007, high gas prices. We've talked about this. We talked about why they started happening. $1 per gallon tax credit on biodiesel. So we were incentivizing the use and production of biodiesel during this time. And as you can imagine, this just helped this expansion even more in the years of the 2000s, the early 2000s. Not only that, but biodiesel, like I mentioned before a couple of minutes ago, created less air pollution. Hopefully, environmentalists would like this. We were taking something that was waste, that was going to get dumped, that really had no purpose, and we were, quote, recycling this waste into something that we called biodiesel that we could put into our cars and run. Not only that, but after it is used up, it's generating products that those products are not as dangerous or toxic to the environment as normal diesel would be. Oh, it's a win-win for everybody, right? Well, here's a chart. 2010 to projected of 2050. And you see ethanol production. But you also see biodiesel production. Here's biodiesel right there. Pretty sad. As you can tell, there's really no projected growth in the area. Biodiesel production staying pretty constant at this point. Ethanol production staying pretty constant. A tick up, not much. Other biofuels, we talk about those in another video, but those are kind of staying constant. So it looks like if we could take waste, and if we can convert waste into something that we could run a vehicle with, and then that is actually causing less pollution, less toxins to go up into the atmosphere that everybody should be happy with, it looks like this would kind of take off from this point, right? Well, remember history. It's a roller coaster. It goes up, it goes down. There's a need, then it goes away. There's a need, then it goes away. We saw biodiesel in the early 1900s. We saw biodiesel in the 1930s. What do you think is going to happen? Well, everybody should be happy, right? Wrong. And this is where we'll pick up in the next video. Why weren't people happy? As you can imagine, this debate about food versus fuel comes around again.